Question number 7. CCl4 liquid becomes graphite carbon and chlorine gas. So this equation, this is a non-spontaneous process. So not everyone may know this reaction. This is just one of the reactions that is commonly found with dry cleaning fluid. And so this is not going to be a spontaneous event, and we'll see, as we do the calculation, we'll see what happens. So let's first calculate the delta H. So the delta H is just going to be minus 135.44 for the CCl4. Because this in its standard state is 0, this in its standard state is 0. Okay, so this is just 135.44 kilojoules. Let's calculate the change in bond energy. So there's going to be no change, there's going to be no bonds for the graphite, right? But there's going to be bonds for the chlorine, so, and the carbon chlorine. So the first one is we're going to do the bonds being broken minus the bonds being formed. This is going to be about 874 kilojoules. Okay, so now we can calculate the delta N of the gas. The delta N gas is going to be 2. That means work is going to be done by the system because it's positive. So if we do that, we're going to get negative delta N RT. That's going to be about, so remember R is 8.314 joules mole Kelvin, and this is going to be 300. We're going to round to 300 Kelvin. This is going to give an answer of about minus 5 kilojoules. Okay, so remember, negative work is work done by the system. The system is losing energy. Okay, so now let's also calculate the delta N of the system. This is going to be, so 1 mole here, and then we have 3 moles. So this is again going to be plus 2. So let's calculate the delta S. So for carbon, it's very small, 5.740, and then we have 2 chlorines, and then we have 1 CCl4. This is going to be about 235.48 joules per Kelvin. Now to calculate T delta S, we're going to do 300 Kelvin times 235.48 joules per Kelvin. That's going to be about 70,000 joules, so about 70 kilojoules. Okay, so now we can calculate delta G. So delta G is, well, we've done this many times now, delta H minus T delta S. We have calculated both these values. So the first one is 135.44 kilojoules minus 70 kilojoules. That's going to be about 65 kilojoules. So this is going to be a non-spontaneous process. However, since entropy is positive, it can be a spontaneous process if the temperature is high enough. So if the temperature is high enough, this term can overpower the delta H term, and therefore the process can be spontaneous. So this process can be spontaneous at extremely high temperatures.